welcome to Lavanya chemistry classes. In this video lesson, we can understand the concept of p block elements and halogens family. The main 4 marks question in the board examination is oxoacids of halogens. What is that? Oxoacids of halogen. In oxoacids of halogen, the fluorine does not form any oxoacid. That means in halogen family containing fluorine, chlorine and bromine, iodine, these 4 are formed. In these 4, the fluorine does not form any oxoacid because fluorine is the strongest oxidizing agent. Why fluorine forms any oxoacid is because fluorine is the strongest oxidizing agent. And the remaining 3, chlorine, bromine, iodine, mainly forms 4 series of oxoacids, namely HXO, HXO2, HXO3 and HXO4. That is, in HXO called as a hypochlorous acid, HXO2 halous acid and HXO3 halic acid and HXO4 perhalic acid. These are constructed as a one tree diagram. HXO is called as hypochlorous acid. In the HXO, X is a halogen, any halogen, that is like chlorine, bromine, iodine. These 3 forms only oxoacids of halogens. Fluorine does not form any oxoacid. In HXO, the halogen group, the oxidation state of halogen is +1. In HXO2 the halogens, the oxidation state is +3. In HXO3, X oxidation state is +5 and HXO4 having a halogen oxidation state is +7. In chlorine forms HClO, HClO2, HClO3 and HClO4, and bromine forms HBRO and HBRO3, HBRO4, and iodine forms HIO, HIO3, HIO4. In the order like acidity, chlorine, bromine, iodine, the order will be decreases and the thermal stability is increases. In HXO, HXO2, HXO3, HXO4. For going HXO to HXO4, the thermal stability increases, oxidizing power will be decreases. What happened to this? Acidity is decreases and the thermal stability from HXO to HXO4 is increases. That means HXO4 having a thermal stability is more than HXO3, then HXO2, then HXO. The oxidation power is decreases. Mainly oxoacids of chlorine is HClO, HClO2, HClO3, HClO4. In HClO4 is called as hypochlorous acid. In this, ClO is an anion. In this ClO arranged into the bent shape like this. The bond angle between the H and chlorine is 103 plus or minus 3 degrees. And the bond lengths are oxygen and Cl is 169.3 picometers Actually, bond length is measured in picometers, and the hydrogen and oxygen, the bond length is 97 picometers. In the second one, HClO2, that is called as chlorous acid. In the chlorite ion, ClO2 minus, HCl is when removed, the shape of the molecule is like this. And the third one, chloric acid, that is HClO3. The ClO3 is called as chlorate ion. This is called as anion. ClO3 minus is called as anion. These are arranged in like this. Cl, pyramidal shape, trigonal pyramidal shape. And the fourth one, perchloric acid, that is HClO4. In the perchloric acid, the perchlorate ion is ClO4 minus. These are arranged in like this. The shape of the molecule is tetrahedron, and the bond length between the carbon and oxygen is 163.5 picometers. In this 105 8 degrees, and the carbon and O, C double bond O, is the bond lengths are 140.8 picometers, and the bond angle is 112.8 degrees. These are the oxoacids of chlorine. Mainly, oxoacids of chlorine forms 4 types of oxoacids of chlorine are formed: HClO, HClO2, HClO3, HClO4. In this anions, hypochlorite ion, chlorite ion, and chlorate ion, perchlorate ion. These are the structures of oxoacids of chlorine. Thank you. Please subscribe and share.